All right, so let's take a look at this first question here. We have 3 3/8 minus 2 1/4. And we're dividing that by 1 1/2. Let's get our pen here. Right. So the first thing we want to do with this question is change our mixed numbers into improper fractions. So 3 by 8 will give me 24. 24 and 3 will give me 27 over 8. Minus 2 by 4 is 8 and 1 9. 9 over 4. And underneath here we have 1 by 2 will give us 2 plus 1 is going to give us 3 over 2. All right. Now, some students tend to separate the numerator and the denominator here. We want to work everything together. So on top, we have 27 minus 8, 27 over 8 minus 9 over 4. We want to equate the denominators here, meaning that we want both of them to be the same thing. So what we will do is think of our LCM of 8 and 4, which is going to be 8. So we want the denominators underneath here to both be 8. That means that I'll multiply 4 by 2 to change this to 8. And if I'm multiplying here by 2, I also need to multiply up here by 2. So look at what will happen. We'll have 27 over 8 minus 9 2s are 18 over 8. Now that the denominators on top here are the same, let's go back this. We're not using this right now. It's easy for us to subtract 18 from 27, right? And that's going to give us 9 over 8. Now that we have worked out the top here, we could then rewrite this differently. This line here implies division. So I'm going to put a division sign. I'm going to put 3 over 2. When we divide in fractions, we want to change this division to a multiplication. Flip this fraction. So the 2 goes on top, the 3 goes underneath. And we're going to cancel. We can cancel here. 3 into 3 will give us 1. 3 into 9 will give us 3. We can cancel it. 2 into 2 will give us 1. 2 into 8 will give us 4. That's going to leave us with 3 by 1 to give us 3. 4 by 1 to give us 4. So our answer for this question is going to be 3/4. Right, so when you're working this one out, you want to make sure and include your bracket. So 2.86 plus 0.75. That's going to give us 3.61 plus 0.481 squared. Right? Again, you might want to include your brackets there so the calculator would know to square that figure first. And then add it to your 3.61. So when we square that, we will get 2.31361. This is our 3 here. Now you don't have to write this out, right? I'm just writing it out so it's easy for you guys to follow on screen. I mean, you could plug these values into a calculator and get your final answer and then approximate it to 2 decimal places. I just want to show all the working so it's easy for everybody to follow along. So I'm adding 3.61 to 0.231361 and I'll get 3.841361. Right. So we want to write this to 2 decimal places, yeah? So this is our decimal point. This is my first decimal place, second decimal place. Let's draw a line here because that's where we want to approximate it to. We're going to look at the number after the line. If this number after the line is 5 or more, then we could round it up, right? Because it's 1, we will not round it up. And we will write our answer as 3.84 to 2 decimal places. It's very important for us to remember to put that approximation amount after the 2 decimal places. Yeah. sorry. If you're getting a discount of 5%, we have our cost price of the computer being 1,064, the mark price of the computer being 1,399. So this is what you would sell it for. If you pay by cash, you're getting a 5% discount, right? So they want us to calculate the selling price when we pay by cash. So if you're getting a 5% discount, we are actually paying 95% for the computer at this mark price of 1,399. So to find my selling price, I could simply multiply 1,399 by 0.95, right? Because that's 95%. And that would give me my selling price of the computer. So 1,399 by 0.95, that's going to give me a figure of 1,329.05. And this is our selling price, right? The next part is to calculate the profit or loss as a percentage of the cost price. Now, before we can calculate it as a percentage, we need to identify what the profit or loss is. So it is a profit because our selling price is more than our cost price. So selling price minus cost price will give us our profit. So we have 1,329.05 minus 1064. Now as we can now tell you a profit of 265.05. Now, to get it as a percentage of the cost price, we will write the profit over our cost price and multiply by 100. So the profit of 265.05 over our cost price of 1064 multiplied by 100. So dividing by 1,064 and we multiply by 100. Now we could probably put this to one decimal place. So I'm getting 24.9% is our percentage. The profit percentage of the cost price. Yeah. Part C. We have 3 carton sizes, 350 ml, 450 ml, 500 ml. And we want to calculate which size of orange juice is the most cost-effective buy. So what we want to work out is probably the cost per ml, right? So cost per ml. We might need to do a little bit because you're going to get some very small numbers. So we divide. This is, let's label them 1, 2, and 3. 1, 2, 3. We divide the selling price by the number of ml, so we know what's the cost per ml. So 420 divided by 350. This is going to give us 0.012. Then we'll do 535 divided by 450. That's going to give us 0.0118. Those two are very close. And then we do 580 divided by 500 ml. And that's 1.16, which is far off. Now, because how close these two are, let's do something here. Let's multiply all of these by 1,000. So we'll find the cost for a liter, right? So sorry, I wrote this incorrectly. This is 0.0116. So I'm multiplying by 1,000 because the way in which all of these are very close to each other. It's going to make it easier for us to distinguish between them. So 0.01 2 by 1,000. If we shift the decimal point 3 spaces, we will get 12. If I shift this one 3 spaces, I'll get 1180. If I shift this one 3 spaces, I'll get 1160. So which of them you think is the best buy? Best buy would have to be 3. 500 mLs for $5.80. Yeah? Let's take a look at these. First one, we have to factorize completely. Now, when you have a question that requires you to factorize, you need to look at the question because you have different types of questions. So when we look at this, one of the clues that we see here is we have 2 terms. The other clue is that we have a minus sign in between the 2 terms. Now, anytime you see you have 2 terms and a minus sign, you should begin to automatically think about the difference of 2 squares. The next thing you want to ask yourself is, are these numbers on either side of the minus sign perfect squares? If you could write each of them as the square of a particular number. So, for example, 4 is 2 squared. We already have a squared. And 16 is 4 squared. So these are all perfect squares. If we could do that and write them as perfect squares, then it means that this is the difference of 2 squares. And when we have the difference of 2 squares, for example, a squared minus b squared, to factorize this, what we will get is a plus b and a minus b. In this instance, our 2a all squared is our a value, and the 4 is our b value. So if we factorize in this, we could write this as 2a plus 4 by 2a minus 4. Yeah? All right. So part 2, we have 3y squared plus 2y minus 8. This is a difference of, this is a quadratic expression. So we have to use our first by last method in order to work this one out. Right, let's bring it here, let's make it a little bigger. So first term by the last term, that's what we would usually refer to as our a by c, is 3 by negative 8. That's going to give us negative 24. We need 2 numbers that we could multiply by each other and get negative 24, right? So for example, 6 and 4, 12 and 2, 8 and 3. But we must be able to add and subtract those 2 numbers and get a plus 2. So we can't get a plus 2 from this, nor from this. This is our possible or most likely pair of numbers that we could use. Now, if you want to get negative 24 when we multiply and positive 2 when we add or subtract, it should imply that we should use a plus 6 and a minus 4. Because plus 6 multiplied by minus 4 will in fact give us the negative 24. And if I have plus 6 minus 4, that will give me plus 2. So I'm going to split this middle term to be plus 6x minus 4x minus 8. So all we have done is literally rewrite the original quadratic here, or the trinomial, and split the middle term. So we have 4 terms. That's what's going to allow us to factorize, because now we could look at it in groups or pairs. We could look at 3y squared plus 6x and factorize that. Previously, we would not have been able to do that with 3 terms. So looking at these 2 terms here, if we factorize in, if we look at the numbers first, the common factor, or highest common factor between 3 and 6 will be 3. Because 3 could go into 3 and 3 could also go into 6. Right? I make a mistake and put x here. So accustomed using x and not y. Right. So all y's, right? My bad. Then between y squared and y, our highest common factor is going to be y. Y could go into y squared and y could go into y. Now, to get the contents of our bracket, we are simply saying 3y into 3y squared. Or if we take the 3 and a y out of this, what would we remain with? We remain with a y. plus 3 into 6 will give me 2. The y into y would cancel and I'll get 1. So this is the fully factorized part or form for this first half of our expression. Now, a trick that we could use here is instead of trying to factorize on this side, because some students try to do that and sometimes wind up getting the wrong sign in the bracket. Copy the exact same bracket across on this side, because the brackets have to be the same. After you do that, you could compare the coefficient of this term with this, and you will see what your missing value is here. You need a minus 4 to multiply by this y in order to get back minus 4y. And minus 4 by plus 2 will give us back the minus 8. Right? Now that these two brackets are the same, we could factor that bracket out, y plus 2. And we could put these two here in our bracket on their own. So you get 3y minus 4. And this is the fully factored form of 3y squared plus 2y minus 8. Yeah? Next question is to solve the simultaneous equation. We have here 2x plus y is equal to 3, 5x minus 2y is equal to 12. They didn't specify which method to use, but in a case like this, I would probably use my substitution method because I have what I refer to as a lone y here, a y standing on it by itself, right? So I can make that y the subject of this formula by moving this 2x across it. So I get y is equal to 3 minus 2x. Now that I have y is equal to 3 minus 2x, I can simply say substitute y is equal to 3 minus 2x into, this is equation 2, this is equation 1. We'd substitute it into equation 2. So I have the equation 5x minus 2y is equal to 12. Right here, I want to substitute that value that we just spoke about, that expression. So look at what I'm doing, right? Where I have y, I'm replacing it with this entire bracket here. 3 minus 2x. All right? Is equal to 12. Everything else remains the same. Here's my 5x. Look, I still have the minus 2 here. Look, I still have the 12 here. Right? All I replaced was the y. In doing that, I now have an entire equation that is expressed in x only. So if I multiply negative 2 by the contents of this bracket here, what I will get is negative 6. A minus by a minus will give me a plus. 2 by 2 will give me 4x is equal to 12. I could then solve for my x's. Right? These two are going to add together. I'm going to get 9x minus 6 equals 12. If I move this 6 across here, I'll get 12 plus 6, right? Because use minus to be plus on this side. X is equal to 12 plus 6, which is 18. 9x is equal to 18. So x is equal to 18 divided by 9. X is equal to 2. Now that I know x is 2, I could substitute x is equal to 2 into y is equal to 3 minus 2x. And what will I get? That will give me 3 minus 4, and y will be equal to negative 1. So my answers to this question would be x is equal to 2, y is equal to negative 1. Yeah? Right, let's look at this table here now. So this is a variation type question, right? With variation, we have what we call direct variation and indirect variation. With direct variation, as one value changes, the other changes in the same proportion, right? That's why sometimes you would see it's referred to as being directly proportional. So if one value increases, the other increases also. For example, when you go to the gas station to fill gas, the amount or the volume of gas that you put in the car is directly proportional to the amount of money that you'll spend on the gas, right? If gas is $7 a liter, If you put 10 liters, then you will pay $70. If you put 20 liters, then you will pay 140 liters. If you put 30 liters, then you will pay 220 liters. So the more liters you buy, the more money you spend. That's an example of being of direct variation or being directly proportional. As one value increases, the other does the same thing. The opposite of that is indirect variation, right? Or indirectly proportional. An example of that might be going from one place to another and increasing its speed. The faster you travel, the shorter the time will take. If we try to go to Tobago via boat versus a plane, there will be a difference in time. Why? The boat is going to travel at a slower speed than the plane. So that's an example of indirect variation. As one value increases, the other decreases. If we increase our speed, we spend less time to get to Tobago. So this question says that y varies directly as x. So it means that as x increases, y also increases. Now, there are two formulas that you need to know for this. One is your direct variation formula. When we are increasing two values at the same rate, we have y is equal to kx. K in this example or in this formula, think about this as the price that you pay per liter. Right? So if this is the amount of money you're spending here, and on this side here, this is the volume in liters, this is how much money you're paying per liter, the $7 you're paying per liter. Yeah? And when we're talking indirect variation, the difference with the formula is now k is over x. Or some people may write it as k by 1 over x. So as the speed increases, the time decreases, right? So here, they want us to calculate the values of t and u. Now, in these questions, they will always give us one set of values where we know what x and y are, right? So we have x is 6, y is 3. Since we have direct variation happening here, what I want you to do is write the formula I give you for direct variation. You'll then substitute known values. So the question must provide known values of x and y, and we're doing this in order to find k, which is our constant, right? So y is 3 when x is 6. So if we have y is equal to kx, we put y is 3 when x is 6. So if we want to solve for k now, we want to find k. K will be 3 over 6, and that will give us a half. Now that we know k, we could rewrite our formula. So we could say y is equal to a half x. So this is the way in which y is related to x, right? Y is always half of x. So if we go back here now, look at this one. We want to find u when x is equal to 10. Go to our formula. Y is equal to a half x. So a half of 10. Y is equal to 5. Therefore, our value of u is 5. Similarly, when y is equal to 9, right? If this is 9 and this is a half x and we want to find x, I have to move this across, right? 9 divided by a half. We multiply on the side. If I move the half over here, I have to divide. A half multiplied by x on this side. On this side, I have to divide. When you divide in fractions, you change the division to multiplication. You flip the fraction, we're going to get 18. So t is 18. Everybody right to that? So let's take a look at this question here. We have a Venn diagram below shows the number of students who study history and French in a class of 30 students. So the entire Venn diagram should have 30 students in it. U is the universal set, which is the students in the class. That's equal, to 30. Students who study history, we have a circle here. Students who study French, next set here. Write an expression in X in its simplest form for the total number of students in our class, an expression, so no equal signs. So we are actually adding each section of the Venn diagram here. So we're talking about 18 minus X, that's this section, plus X, that's this section here, plus 14 minus X, that's this section here, and plus outside here we have 5. That is an expression that represents the total number of students in a class. State whether the following relationships are true or false. So H union F. So H or F, meaning everything in H or F, is equal to the universal set of 30. So if we add up everybody in H and F, would it be equal to 30? No, it wouldn't, because we have this group of 5 or this number of 5 students outside here. So that's going to be a false, a hard false. H intersect, not F. So number of students in history and not in F is equal to the empty set. So the number of people that are in history and not in French, there's still a number of students that will be doing history and not French, which would be these people here in this area here, 18 minus X. So it is not equal to empty set. That is also a hard false. Determine the number of students who study both history and French. So what they want us to find actually is the value of X, to solve for X. Now remember, we wrote this expression up here. So all we need to do is to take that expression. I'm going to write it on the side here. 18 minus X plus 14 minus X plus 5. And we'll put this equal to 30. So let's add our numbers together. We have 18 and 14. That'll be what? 20 and 12, 32. And 5, that's 37. And then X subtract a X, that's, these two X's will cancel. I'll remain with this minus X here. Right? And then for the sake of simplicity, let's carry this here and let's bring this here. So I get 37 minus 30. And I carry the X across, it become positive. So I'm going to get X to be 7. So the number of people that do both history and French, writing in set notation here, is equal to 7. Yeah? Right. So for this question, we are required to calculate the volume of the box using the external dimensions. So the external dimensions would be this 30 cm here, 20 cm this way, and 15 cm in terms of its height. So volume, you could say length by width by height. The length being 30 centimeters, the width being 20 centimeters, and the height 15 centimeters. So let's check that and see what we get. Calculator here. 30 by 20 by 15. We have 9,000 centimeters cubed. Right? That's the volume of the box using external measurements. Complete each of the following statements. The internal length of the box is 30. So we have two lengths here. Minus 2 by 1.25. Right? The internal length of the box. So I guess they want us to calculate this. So, 27, right? 30 minus 3, which is 27 centimeters. So what we mean to say there is that these internal lengths on the inside, 27, because we have to take off this here, and to the front here, here, and to the front here, and the back there. So 1.5, 1.5 is 3, right? So each one of these lengths, even on top of here, this is 27, this is 27. All the internal lengths are 27 centimeters. The internal width of the box now, right? So the internal width is the same thing going to happen. We have to take off the 1.5 here, 1.5 here. So we do 20 minus 2 by 1.5. All right, that's 20 minus 3. That's going to give us 17 centimeters. The internal depth of the box, right? So internal depth of the box, same thing again, top and bottom, but you don't have a cover to the top. The thickness will just be one of them. Underneath here is going to be 1.5. They said that there was no, the sides and bottom of the box are 1.5 centimeters thick. Only the sides and bottom, not the top. So that means we're going to be taking 15 minus 1.5 centimeters. And that'll give us 13.5 centimeters. Yeah, everybody right to that?